That's the Tinkercad window. So now let's see about the HalfAdder circuit using Tinkercad. So breadboard for placing it IC, one more power supply for giving high. So we have taken the power supply. We also need one switch, DP switch. So between a high and low, so we take a switch. We need two LEDs to take our output. So we type here LED and we take two LEDs. So we also need two resistors because LED won't be able to handle such a high voltage. So we are using a resistor. So 330 ohms would be a good choice. So now we connect the LED with the resistor at the cathode and we give the cathode the negative terminal. So similarly for this also, so one from the two LEDs will act as the sum and the other will act as the carry. So we are only using two inputs. So we will use two switches and both we will give them high inputs so that we can change the input according to our convenience. So the positive terminal from the power supply will be given here so that all the green circles visible here are the same points basically. So when I connect this to positive terminal, all these points are connected to the positive terminal. Now this one with the negative terminal. So when I connect one point of this line with the negative terminal, so all these points are connected to negative terminal. So now we need one XOR gate and one gate. So we search XOR here and we place it here. So IC7486. So next one we take as a 7408 because there is also an AND gate and we don't need that here. So it's now basically we need ones to give them power at this 14th pin. So there are 14 pin in both of these ICs. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the 14th pin will be given as a high power. And the 7th pin of both the ICs need to be grounded. So we will connect them with the negative terminal. So similarly, all these green circles are the same point. So even if I connect this point to negative terminal or this point to this negative terminal, it means one and the same. Now we have given power to both the ICs. We have also grounded them. And now we need to take input here. So for the XOR gate, you can see the name appearing here. There are two inputs, one and on B, and from this pin we will get the output of XOR. So we connect here the two inputs and one. Okay, so we gave two inputs here from two different switches. Your numbers now here the input 1 that is taken from the first switch and input 2 input 1 B is taken from the second switch, and now we will take the output from here. So the output 1 pin and we will directly give it to the anode of one LEDs. Now this will act as the sum because sum is XOR, and now for the AND gate, that one A and that one B, that we can take the inputs from the switch, as well as we can take the input from here because all the points here are same as the input 1. So we can also take it from here and give it to the input 1. So on the second input from here, and we can give it to the input 1B. So we can also take it the input from the second switch and the first switch, but we can also take it from here because all the points are same now. So the output we get here is for the carry, and we take it, we connect it to the anode. So basically our HalfAdder is ready, and now we can name it here. So we give sum, here we take carry. We can name it as sum and here as carry. So we can start the simulation. If there is some error, we would resolve it, or else we can have made our simulation part correctly. So we can proceed further. So in HalfAdder, so let's take the input here are low because both the switches are open right now. So let's start for 0 0 0 0 the input. So we get the output low. So this is some reference, the truth table for a HalfAdder. So now for 0 0 input, both the sum and carry is 0 0 only. And when we are giving the input 0 1, we are getting sum as 1 and the carry as 0. So the LED is glow here. Then for the input 1 0. So 1 0 means the same thing, sum is 1 and carry is 0. So again this sum LED that is glowing. And when we are placing both inputs are as 1 1 means now we are getting carry as 1 and the sum as 0. So it has been verified from the truth table. We have made the circuit clear, and this is how it is working. So this is a basic model of how the circuit of the HalfAdder is works.